Hello, everybody. Welcome to session 6, Anthony's Problems. All right, so we were going to get into Anthony a little bit later, but I wanted to discuss the tiles pool graph and worksheets with you just so that we are all on the same page and you can understand why we came up with the data that we came up with. And then when we're done, we will help Anthony make a great life decision. And then when we're all done with today's lessons, you have student book page 220 to complete. And in your home connections book, there's a few here, 115 to 118, 4 pages. All right, so let's go ahead and look at your tile pool graph. When you finished that graph, you hopefully found that I'll move that over to the center. That looks a little bit better. We were able to, in that first section, kind of count the number of tiles needed to surround each of the 5 arrangements for our pool. We kind of did this yesterday. There was 8 to get around the first one. There was 12, 16, 20, and then 24. We also noticed that they went up by 4. So if I go and compare this to my other graphs that I have done previously, I'm going to picture this graph going up in the same sort of shape in a straight line because with each arrangement, it moves over 4 spots after starting with 8. The second graph we had, or I'm sorry, the second set of data that we had to figure out was how many tiles does it take to make the pool? And in the first pool, we only had 1 tile. The second one, we had 4, then 9, then 16, then 25. That's all work that we had done previously. And then you came up with ordered pairs. Now, when we turn the page and we go to our graph, there's what our graph it looks like. Our graph for our blue line, and I will put that in blue so you all see, because that's our pool water, starts here and then works its way this direction, while our border works its way this direction. Why do you suppose that is? Think about that a little bit. So one of the things that when we're dealing with coordinate graphs and we're putting out our data is recognizing whether we have a linear pattern or a nonlinear pattern. Now, a linear pattern is a pattern where data is going to increase at a constant rate, right? We're going to see a straight line. It's either going to be up, it's going to be down, but it's going to be a straight line. I know my lines aren't very straight, but drawing on a Chromebook is not very easy for me, but for you, probably a little bit better. On nonlinear patterns, data is going to increase and decrease at variable rates, meaning when we jump from one arrangement to the next arrangement, it's not the same as we move to the next arrangement and then the next arrangement. So we have graphs that go up and down. They are curved in length, or they are curved in shape. So which are which? Which graph here shows linear patterns and which one shows nonlinear patterns? So our red graph, right? Our red line shows the pool borders. And we found that when we went from arrangement or pool to pool, we increased 4 after starting with 8, correct? So we went from 8 to 12, from 12 to 16, 16 to 20, 20 to 24. So because the data is increased at a constant rate and it is a straight line on the graph, we would call that a linear pattern. A nonlinear pattern is the pool size, right? Because we started with 1 and then we went to 4 and then we went to 9, and then 16, 25. Now just think about a pool that's 10 by 10. That's 100. What do you think the border is going to be with that? You found that out in the next one, so I'm not going to jump ahead there. So I'm just going to erase a little bit of this, and we're going to move on. All right, for your next page, the next 2 pages, you had to deal with answering some questions using the arrangements. So it said, how many tiles would it take for the 10th one, right? So to make the pool, it's kind of easy. It's a 10 by 10 arrangement, right? For the first one, it was a 1 by 1. Second one, it was a 2 by 2. Then a 3 by 3. Then a 4 by 4. So we could only assume that the 10th arrangement, or the 10th pool, would be a 10 by 10, and 10 times 10 is 100. Okay, pretty easy, right? So how about the border? Now, this one was a very interesting one when I was working this out with my kids. So think about your 10 by 10. This is 10, and this is 10, correct? Then when I draw my border, I had to ask myself, how many tiles does it take to make that border? And I knew that it was 10. And then I had to go, well, here, if I make the border here, that's 10. And if I made my border here, that would be 10. And if I made my border here, that would be 10. So that's interesting, because that's not the whole border, because I also have to add 1 here, 1 here, 1 here, and 1 here. And as I was drawing this out with my kids, I realized that, well, I was multiplying 4 times 10, right? And then I was adding 4. So it would take me 44. It would take me 44 tiles to build around my 10 by 10 or my 100 square units. Pretty cool, huh? So then how would we find out how many tiles it would take to build any pool? Well, that's an interesting question, because in our first arrangement, it's a 1 by 1, so we multiplied 1 times 1. And then for our second arrangement, we multiplied 2 times 2 and got 4. Third arrangement, 3 times 3. And if we look over here, we did a 10 by 10, which was 10 times 10. So for any arrangement, I would have to put a letter in for that, and we can use the letter N. And then we're going to have N twice. We're not going to go 2N. It's N times N, right? So when we go N times N, that's going to give us the total. But we have this thing called exponents, and we can combine our n's. And when we combine n's, we're not adding, so we wouldn't say 2n. But we are multiplying n by n. And since we know exponents, we would say that would be n squared. And when we do n squared, we're not taking 10 times 2, we're taking 10 2 times, multiplying, so 10 times 10. If it was 10 to the third, we would go 10 times 10 times 10. If it was 10 to the eighth, we go 10 times, I guess you get it. So then in number 4, it asks, well, how do you figure out the amount of tiles to go around any pool? So then I went back to my original plan when I was working with my students, and I saw, if this was a 10 by 10, and each one of these were 10, I would have to multiply 4 times the arrangement, regardless of what it is. And then I also had to consider each one of the corners. So then I had to add 4 more. And then that was the aha moment for us. We're like, what? That works. And we try 200. How many would it take to go around the 200th pool and whatever? And it was kind of fun for us to kind of work out. Number 5 is a little difficult question. It says, what would it take, right, if we had, and my reading eyesight isn't so well, but you have 196 tiles. So you have to figure out how to do this. Well, we figured out, and when we first started this, we started it with 10 by 10. And when we figured out a 10 by 10, or the 10th one, we knew because of the work that we did with this one and this one, it was 144. So then it wasn't a 10 by 10, but we knew that it would be greater than 10 by 10. So then we went to an 11. What about an 11? 11 by 11. So 11 squared would be 11 times 11. Do you know what that is? So 121. And then we had to multiply 4 times 11, which was 44. And then add another 4, which was 48. And we got 169. We need 196. So that didn't work for us. So 11 was still too small. So then we went to 12. 12 squared was what? What's 12 times 12? Right, it's 144. And then we input the 12 into the n over here. So 4 times 12, which is 48, plus 4, which is 52. And then we added 52, and we got 196. But this one is all trial and error. So you just had to do your best with guessing, knowing that the 10 was what it was, so that we could start relatively close, because 10 was 144 and we only had to get to 196. All right, so if you still have questions with that, I'm sure any of your teachers would be happy to go over this with you, because we're just sitting at home waiting for you to contact us. I'm just kidding. Any emails you send, we'll get back to you, and then we'll get in contact with you and help you through this. Okay. Now, on to Anthony's problem. So let's take a look at Anthony's problem. Okay, there you go. So Anthony is in junior high school. For some of you that don't know what junior high school is, it's the same thing as middle school. Here where we live, that's your 6th and 7th grade year and 8th grade year, right before high school. It's the in-between place between elementary school and high school. And he decided to get a job for the summer so that he could put some money away for his college account. His goal was to put $1,000 into his account, but still have time to rest up for school to start again. He's a very good math student who loves computers, and he was lucky enough to be offered 2 jobs with 2 different rates of pay for the software companies. So company 1 offered to pay Anthony $1 on the first day, and then double that amount each day. So meaning that he would get $1 on the first day, $2 on the second day, $4 on the third day, and so on. Company 2 said, we're not going to mess around with that. We're going to offer you $75 every single day. Which job should Anthony choose if he wants to reach $1,000 as quickly as possible? I'll give you a little hint. He will reach $1,000 with both jobs. But which job will he reach 1,000 quicker? So go ahead and make a prediction. Which one do you think? Company 1 or company 2? I like the idea of making $75, but I also have some things that I remember a teacher once telling me about the idea of doubling. So I'm not so sure which one to choose. So you decide yourself. All right, so now we're going to look at Anthony's problem. This is going to be the beginning of your student book on page 217. So if you want to go ahead and start this with me, and then you can finish the rest of this on your own. But let's go ahead and look at how this is going to work. All right, so you have one graph here with company 1. Company 1 on day 1 is going to pay you $1, which means your running total here is $1. Correct? So that's how much money you have earned after one day. Day 2 says that he earned $2. So now I'm going to add 2 to my running total and make that 3. So now I have $3 total. After day 3, we then get paid $4. So now I'm up to seven whole dollars, right? And then after day 4, I have $8. So now I'm going to move that up to $15, right? And then day 5, I then double it to 16. And now I've added 16 to my 15, and now I'm up to $31. On the other company, right, I'm going to start at $1 or 1 day and make $75 that first day. On day 2, I'm going to add another 75, and I'm going to have $150. Whoa. Day 3, you're going to add another $75. Now I'm up to $225. Whoa. And day 4, I'm up to 75, another $75. Now I have $300. So how much money do I add on day 5? Right. Another $75. And then I'll add that to my running total. I have $375 compared to the $31 over here after day 5. So it's looking pretty good for one job. I'm not going to tell you which job it is, but what I'd like you to do, if you can, is go now, open your books, or go ahead and finish page 217 and 218 with the graphing patterns, and then answer the questions that you might have on page 219. Go ahead and stop the video and complete your exercise. Start it when you're done. All right, so apparently you are all done, and we can go ahead and figure out which one you thought was best. Which payment plan turned out to be the best? Which one do you think? Right, it was plan number 1. Were you surprised by plan number 1? I know I was, because you take a look at our first initial work through the first 5 days, and it was $31 for day 5 for one company, and the other company had $375. It almost seemed like that company 2 was going to take off, right? So how long was it until you knew plan 1 was actually going to beat it? Well, if I look back here, I'm going to say for day 10. I think day 10 is when we as a class kind of figured out that that was the day that it was going to pass. If you're interested also in a story to read that deals with doubling, it's kind of a really good story to read. It's called The Raja's Rice. I forget who it's by, but it does go over, it is a story that deals with doubling and rice and a chessboard. Kind of interesting, but go ahead and break out that book, or if your teacher has it, maybe they can read it to you online and you can kind of be entertained by it. But same sort of principle dealing with Anthony's problem. So which one of these patterns showed linear growth, right? Linear growth was constant growth, right? He did grow. He got more money, but there was one plan that grew the same amount each time. And which time was that? Right. Company 2. Company 2, it grew in a more linear pattern. Company 1 was non-linear. It ended up, if you would have drawn your line and connected the dots and actually even continued all the way through the remaining days, it started out really low. I believe it didn't even cross the first line until the 3rd or 4th day, and then shot up really quickly, a definite curve in your graph. So which format do you think was most effective for communicating this results? Was it on the table or the graph? Well, if you're going to show, like if you were Anthony's accountant and you were putting this presentation together, which one would be better for you to show him? Would it be the table or the graph? I think the graph, right? The table, numbers are cool. Numbers are fine, but things can get lost in the numbers. but all you have to do is show me a line and see all of a sudden it shoots straight up. That's the one I'm going to go with. That's where I'm going to make more money. Even though I might start out lower initially, later I'm going to get more money. Now, if Anthony had chosen to work for the company, how much would he have made by the 200th day, the 100th day, or the nth day? Ooh, good question. How are we going to figure that out? Well, we would have to continue adding up all of the other stuff, right? Company, oh, no, I'm sorry. I'm thinking company two or company one. Company one, we'd have to multiply 20 by 20 and get 400 or 400, right? But then we would have to increase or count all the money previously. So that I can't do. But what we can do for company two, right? Since we were increasing it by 75 each day, we would just multiply 20 times 75, right? So for the 20th day, 75 times 2, I know is 150. And then adding a 0 gives me $1,500. How about the 100th day? Right? So we know when multiplying by 10, all we have to do is add the zeros. So I have 7,500. And now for the nth day. So I would just have to multiply the day by 75. Cool. Let me go back to that first day. Remember, I said you just have to multiply. I got the tile pools mixed up with that. Mr. Keller makes some mistakes sometimes. It's not always. It's very rare. So you caught a rare moment of me making a tiny mistake. All right, so we've come to the end. Hopefully you've learned a little bit, and hopefully, you know what? Do me a favor. If mom or dad are not around, go ahead and try this with your parents and say, you know, mom, dad, I know times are tough. I don't want to take. I don't want you to think that you owe me allowance every week because I do so many chores for you. Why don't you ask your mom? You know, instead of paying me like, I don't know how much you get for allowance, but you can kind of negotiate $25 a week. I know that seems kind of high, but just say, mom, just go ahead and, you know, I'll take a penny on the first day. So instead of, just even say, instead of $5 for my allowance a week, put a penny on the first day. And then on the second day, I just want you to double it. Give me 2 pennies. And then on the third day, double it again. Now I'm up to 8 pennies. And just say, I'll be more than happy if you just pay me like that. And then work with them and see how much money. I think by the time you're done with the end of the month, you're going to be a millionaire. So, but don't share that secret with them. Just try to get them to agree to it first. All right. So your last time, or the last thing you have to do today is some student book. Remember, page 220. And any home connections pages, 115 to 118. That's 4 pages, right? So plan your time accordingly. If you are done early and you still want to improve some math skills, go ahead and work on your Unit 6 online resources or any of the Number Corner online resources that we have made available to you. There are lots of great resources out there. If your teacher has you hooked up to Prodigy, which those of you that haven't tried Prodigy, you need to try Prodigy. It's a pretty good, it's a pretty cool math site where you deal in wizardry and spells and battle like things. So it's very similar to like a Pokemon, but a little different. So hopefully things went well for you today, and we will talk to you later. Enjoy math. Again, email your teachers if you have any questions.